my co-chair, Branko, is going to do it. And he's going to demonstrate bridge out concrete system showing live measurements. And the clock is started.
Okay, today I will present a monitoring system for Tacony-Palmare Bridge that is between Pennsylvania and New Jersey, built in 1929 and supposed to say forever in accordance to Burlington County Bridge Commission, who is partner on this project along with the other companies and universities with me. Particularity of the bridge is the bascule in the bridge that opens and closes for the bridges that are going over the Delaware River. And that's what we are monitoring: structural performance, so is the bridge safe? Operational monitoring, did the bascule open and close properly? And also we monitor traffic safety, is the traffic safe in case of icing, wind, rain, and so on. So there are several sensors that are present on the bridge, dynamic, static. That's what is important thing is that we have cameras and we try to synchronize the camera images with the measurements. And we developed a special software package for data management, and I will actually demonstrate the second and third part of this software package. So as a first step, I will connect remotely to the bridge. And that's what you can see here on the screen is in the left corner here, we see small scan of the bridge, we see position of all the sensors and position of all the cameras. In these two cameras images, we can see, for example, the mechanism for opening and closing the bridge, and we can see the shear lock of the bridge, so when the bascule is closed, how it looks like. And that what is probably more interesting is to see what is the traffic condition on the bridge at this moment. So we can change the camera view and see actually the traffic on the bridge. In this area here, we have static measurements that are actually indicated simply by level of the strain in the structure, because those are static, long-term, slow developments in the structure. And in those two diagrams, we can see live measurement. So this is exactly the strain that happens now on the bridge under different traffic. So if we are lucky over my presentation to see some heavy traffic, you will definitely see some deformation due to the heavy traffic. That what is nice is that we can configure and show whatever sensor we want or group of the sensors that we want. We just have to scroll this list. And finally, in this window here, we have some important data that tell us is the bridge correctly closed and what are the weather conditions. The system is now under alarm because some sensor exceeded the threshold, and here you can see what sensor exceeded the threshold. And also here you can see the list of the logs that happen on the bridge. So if different things happen on the bridge, you have the log files and you can quickly see what happens. There are several views, I will not go through all of them, but for example, this view allows you to see again all four cameras, to see exact location of the sensor, and by color identification to see what is the state of each sensor. So you can see the sensors in alarm are here, and the sensor in pre-alarm are those sensors here. Okay, so now, once you collected some data from the bridge, you would like to see this data, and for this purpose, we developed a special software that we call Playback. So the Playback software looks like this. Unfortunately, I don't have original PC that I wanted to use, so we cannot see the whole screen. But in upper side, you have four cameras. Here you have the diagram where you can select multiple sensors or only one sensor. Down you have, again, color coding for the various sensor states. And here you have the static data of the state. Here you have the opening of the bascule. You can simply start playing with your data. So for example, if I play, that's what you can see. You can see okay, let me go up so we see how the traffic moves. Okay, we will see one event of opening of the bridge. Okay, so now you see the bridge start to open. So at any time, if you want, you can stop. You can change the time step. So if you want some fine analysis, you can make step of 0 to 2 seconds, for example, and then start measuring. And then also if you go down, you can see here how the values of the sensor change by color identification, and you can figure out if some of them are in some critical state or not. You can basically at any time accelerate or decelerate the thing. So you can, for example, now it's open, so maybe you want to go faster, so you can skip some measurements. You just move like this, so it is more open. So maybe you can see the ship passing through. Yeah, here it is. Okay, so then we can move forward to see the closing of the bascule. Okay, and this is basically, there are several windows that I can more show, but I think this illustrates very well how the software works. You can select whatever sensor you want, whatever group of the sensors you want, and also I will finish now. I also want to point that you are not the only observers of the event. If you look here, you can see the falcon that was thoroughly following opening and closing of the basket. Okay, so if you have any question, please let me know.
It's amazing, we're staying on time. The next demonstration is by the Metis Design Corporation, and they're going to demonstrate